Here we're given the equation of a parabola and the equation of a line, and we're asked for two things. We're asked to find the points of intersection of the parabola and the line, and we're asked to find the area enclosed between the two. So whenever you're asked to find the intersection point of two graphs, say you've got y1 and y2, to find the intersection point, you need to solve simultaneous equations. You need to equate y1 and y2. So that's the first thing you need to do. So it doesn't matter which one you choose as y1 and y2, but you need to equate the two. So that's our first curve and that's our second curve. So we just equate y1 equals y2. And you'll notice you have a quadratic here to the power 2. So the best thing is to move everything to one side so you have 0 on the other side. So if we combine all the terms together, we have a quadratic equals to 0. And the best thing to do when you have a situation like that is to try to factorize it. So you're going to factorize that into your two factors. The benefit of factorizing is that you can then say that each of these two factors needs to be equal to 0, or one of them needs to be equal to 0 for the product to be equal to 0. So that gives us our two solutions. So x equals -1 and x equals 2. So that essentially means the x coordinates of our 2 points here. So A would be where x is -1 and B would be where x is +2. So this would be at A and that would be at B. So that's the first part of the question. The question then goes on to say, find the area, this area enclosed between the two graphs. So to find the area, we need to find the height of these strips, because you're going to divide the area into a number of strips, and then you're going to integrate these strips added together. So the height of this strip will be the height of the upper graph minus the height of the lower graph. So it'll be y1 minus y2, where y1 is this graph, the upper, and y2 is the lower. So to find the area, you'll want to integrate from 0 to 2. These are the limits on x, because we're integrating from 0 to the point B. And at B, remember, we found in part A, for x would be 2. So we're going to integrate from 0 to 2 the difference y1 minus y2, where y1 is given in the question and y2 is given in the question. So we subtract those. Don't forget to enclose y2 in brackets, so the negative sign operates on both those terms. You then simplify by combining the like terms, and then you simply integrate. So minus x squared becomes minus x cubed over 3, x becomes x squared over 2, and 2 becomes 2x. And because we have limits, this is called a definite integral, we don't add a constant. There is no arbitrary constant. We write down our two limits, 0 and 2. Then you substitute 2, the upper limit, instead of x, and then you substitute the lower limit, 0, and you subtract. So it's the result of substituting 2 minus the result of substituting 0. And if you calculate that, it'll give you 10 over 3. And the question asked for the exact area. That means leave fractions as they are. So don't write that as 3.33 because that wouldn't be exact. Leave it as a fraction. So the question says calculate the exact area of the value of the shaded area. So don't forget to integrate between the right limits. You wouldn't integrate from -1 because they're not interested in this area. They're interested in the area from 0. And it's always the upper y minus the lower y. Now, if you make a mistake and you get these the wrong way round, and if instead of y1 minus y2, you subtract y2 minus y1, don't worry, your answer will be right. You'll just end up with a negative sign there. And then you can fix that simply by taking the absolute value, and that'll give you the correct answer.